Alright, for this session, I'm going to show you how to import the CAD model from any CAD tool. Right? For example, you know how any CAD model, CAD tool, right? Like SolidWorks, CATIA, or AutoCAD. So, for example, I'm really familiar with designing the model using CATIA. For example, okay, you can open your CATIA and then you design on your own. Okay, wait for a while, yeah. Okay, but I want to show you the important parts, right, during the designing of the CAD model. You need to create a body, separate body. The reason why, because we need to register different part. Okay, for example, this is other CAD tool, a CATIA. Alright, this is you try to design. Okay, so for example, I want to design a very simple one. Okay. Okay, I want to design the floor. This is my floor. Okay, I do the extrusion. Okay, maybe 10 mm. Okay, I can preview. This is your model. All right. Okay, so you need to rename here as your model. Okay, so and then if you want to create the floor, okay, you can create insert body. Okay, body number 2, you want to create the window. For example, you must assign different parts here when you design in the CAD software. Okay, so you want to create the wall. Okay, for example, I want to create the wall. Okay. Okay. I extrude 100, 1000. Okay, this is my wall. Okay. Okay, for example, like this. Then you design anything else. This is just example. Okay, this is for example your final geometry. Okay, and then you need to export. Okay. Okay, yeah. So, okay. So after you design, you need to export into the selected file. Okay, I show you this file. Okay, you open the SC stream. SC stream. SC stream. Okay. And you open up your preprocessor. Okay. You can actually close this. Alright. It's okay. Right. So if you want to import your geometry, just select file and import. Okay. So this is all your geometry accepted by the SC stream. Okay, XT is the parasolid file. STP stat file is this is the stat file coming from CATIA, coming from SolidWorks. This is DXL. This is STL file. Normally, people will use this file. This is standard file. MDL, okay, CATIA V5, V4, SolidWorks. If you know the SolidWorks, you can design in the SolidWorks file .sldprt OSLDESM. Okay, all these are, for example, IGES and all. Okay, for example, uh, okay. UTHM. Okay, when you access to the GrabCAD, okay, okay, this is the website. Normally, I look at the geometry, the model that has been completed by designer. Actually, this is free. Okay. Okay. The group shop resources. Okay, you need to browse the CAD library. Okay, you can search grabcad.com. You can find any model that you would like to analyze. All right, for example, you want to design for the car. Okay, you just search car. Okay, and this is the geometry. Okay, all right. For example, just showing you. Okay, and from here, you can see that the software provide the CAD tool provide the different format STL, IGS, TAG file, or all this is accepted by the SC stream. So you can actually download. Okay, you need to sign in first lah. Okay. Okay, it's okay. So after you download the model, you can directly import file, go to import and select that model. All right. So make sure you can see this is the file selected, is accepted by the SC stream. All right. So that is how you import the model. Okay. The one that I'm going to show you for this case, actually it is the same case. Okay, as previous case study. Okay, I try to open back the SC stream. Okay, this is the model previously I designed. Okay, we have the aircon, wall, and then the windows. So how to make it nice? We can deactivate the root block. Okay, you can see. We can deactivate the root block. The root block is actually the machine. Okay, we don't want we don't want to loop the machine, so we can deactivate the machine. So just deactivate the machine. So you can see this is your old model. So what I'm going to show you, I want to create a human. Okay, the human being inside the room. So what should I do? Okay, first I must know how to simplify the human. In this case, we are not calling the human, but we are calling the mannequin. Okay, the human model in the cat normally we call as a mannequin. Okay, this mannequin will be placed at the center, for example, at the center of the room. So how to do that? Okay, so just adjust the view. Wait, yeah, I show you the process. Okay, can you see this? Okay, this is radiation. There is the human. Can you see? Human rate of heating. Alright. For this case, they consider the human to be as a rectangular shape. Okay. Don't have any head, just a body. Because in this case, they simplify the model. Alright. So you yourself can do as well. Okay, this is just a simplification version of the mannequin. So first, in order to create the human, okay, first we have to make sure our sketch. Okay, this is our sketch. All right. So it is placed. The human, the mannequin is placed on top of this floor, right? So we must place the sketch on top of this floor first. So how to do that? Press P button on your keyboard and then select here. Now, your sketch plane on top of this floor. If the sketch plane, alright, if you design the leg of the mannequin starting from this position, that means your leg is actually intersecting with the floor. Alright, so you need to start on top of this floor. So you change the location of the sketch plane on top of this floor first. Okay, this is good. And then you can create the mannequin. So how to do that? Okay, you can create using the cubeboard. Okay, I want to create by using the mouse, by mouse setting. Click by mouse, click here, good boy, and then place here. Okay, you can see. Alright. So right click, edit sketch. Okay, part edit sketch. So you can place human anywhere that you like to place. Okay. For example, we can place the human body like this. Maybe the body like this. Okay. We can select the snap so that this will snap in one point. Okay. Okay. For example, this is the human body. Okay, and then we need to have the height. So double click. You can adjust the height in the Z direction. Okay, go to here. Maybe the height is 1,700 or 1,500. So, okay, you can. Okay, before you click apply, you can name this as the human. Alright, or mannequin. Mannequin. Right? After that, you need to assign the attribute to be solid. Right? Okay. So when you assign the human being to be the solid, okay, wait, yeah. human density. Okay, so you need to select others, and then edit mode. You need to create the property for the human. Okay, click others, and then add material. Okay, maybe this is human material. So the density the same like water. Okay, can you see this? Okay, that you need to specify the density of the human the same like water. This is like the blood. Okay, and then specific heat, thermal conductivity. The thermal conductivity is 0.5991. This is as per the water, and specific heat is 41 bits. Okay, right. So after that, we need to set. Okay, we need to set this. Human, we can actually set this. Okay, so we can color. Okay, maybe the color. Okay, now we have the human. So maybe we can create the hits. Okay, so how to do that? You need to change the positions of your sketch plane on top of this. Okay, now okay, you press P button on your keyboard and then click on top of this. It automatically change. So you can create the hit. Okay. Okay, good boy. And then by mouse setting, and then go here. Okay, this is very big. You need to reduce a little bit. Just double click, part edit. Okay, change the size. Okay. Okay. And then you need to adjust the height. Okay, maybe 100. B. Okay. So for the attribute, you need to select solid, and then the human head. Okay, and then click apply. You can actually rename this as the head of mannequin, and then preview, apply. Okay, nice. Okay, I think this is sufficient if you want to simplify the mannequin, the human model. All right. Okay, so from this one, you need to combine the head with the body. So how to do that? Okay, you need to apply the Boolean operation. Okay, so this is the head, and this is the mannequin body, and this is the head. You need to combine. The reason why you need to combine, because later on I want to copy and paste. I want to duplicate. Maybe I want to place another mannequin inside the room. Okay, so maybe 2 mannequin, 3 mannequin. So what happened? Okay, so for this case, okay, this is mannequin. You go to the edit, go to the Boolean operation. So in the Boolean operation, you have many operation, such as the unite A and B, subtract A minus B, intersection A intersection B, and divide, subtract plus intersect. Right. So I want to unite the head and the body. So go here, head, and the body. And you need to name this as the mannequin. Then you can execute. Okay. The reason why, because it's already have the same name. Okay. So maybe you can say as mannequin 2. Alright. If you want to keep uh, the heads, so you can keep here, but keep A. Okay. So I don't want to keep anything. I want to delete. Just execute. Can you see? It's already combined, unite one geometry. Okay. So now this mannequin we can name as a right mannequin. Okay, this is your mannequin. And you can reset your sketch plane. Alright. So I want to create only one, and then I want to copy and paste another mannequin. So first I need to decide, okay, this mannequin having the rate of heating 100 watt. Okay, as you can see here, human rate of heating 100 watt. So go to mannequin. You can put the heat source. That means the heat produced by the human, by the mannequin is 100 watt. Okay. Okay. So the initial temperature of the mannequin, what is your body temperature? Can you tell me anyone? When you scan your, when you go to the shop, what is your body temperature?
30, 36, 37.
36.6, right? 37, more than 37, you cannot go. So it is 36. After that, just stay here, preview. Okay, now you have your mannequin, complete mannequin. So you can see the layout part change the color. This is not the typical geometry. This is the geometry with the heat released from the mannequin. Okay. So for this case, right click and register to library. I want to register this to my library so that I can use again and again. So just right click, register to my library, name as mannequin, register. Okay, and you go to your library. This is the grid panel. Okay, this is layer, and this is your library. Can you see previously we made a table? So we have the table. Okay, we can create a table. Okay, just add and drop, but make sure your sketch plane on top of this floor. Otherwise, your table leg will intersect with the floor because your sketch plane, okay, actually behind the floor, at the bottom of the floor. So just press P button and click here. Okay, in order to avoid the intersection. Okay, and then click table. Now you can see this is like your case, right? You have the table, and you can actually create the chair. Right. So for this case, okay, I want to change the position. How to do that? Okay, press A, right click, go to part edit sketch. Okay, from here you can change here. Okay, nice. Can you see? Okay, I want to have another table. Go to table, another table. Okay, maybe two table and two mannequin. Go to part edit and change the position. Okay. Okay, and then I want to shift this mannequin to another position. Okay, sorry. Okay. Okay, now you can see I change the positions. This is my mannequin. Alright, I want to place another mannequin here. Just drag and drop. Okay, right click, change the position. Okay, that's it. Okay, so far you guys clear on how to do this? Okay.
Okay.
Alright, this is your mannequin. Alright, so if you have a laptop, you can place your laptop. Alright.
Yeah.
Okay, now I want to change the case. Instead of cooling, I want heating. I mean, the ambient temperature outside is, for example, in Malaysia. So you can go to here, wizard, condition, alright. Go to the thermal boundary, and then okay, this wall facing to the X maximum. So where is the X maximum here? Okay, this is under conduction. Okay, double click here, conduction, and you see this is under external temperature 0. Very cool. Okay, so maybe what is the ambient temperature in Malaysia? Normal.
32, 36.
Okay,
Mm.
maybe 40 lah. We try 40. Okay. Alright, this is the external temperature. Okay, and then the X. Okay, conduction, everything. Okay. Right. Conduction at maximum. Okay, we go to the radiation. Okay. Okay. So I want to change the parameter of the aircon here. So this is my aircon. Okay. For example, okay, this is default value temperature. I want the default value temperature of the room. For example, the room is 26 or 25. And the initial solid temperature maybe 25. Okay. Alright. So this is the aircon. I want to change the aircon setting. Go to here, condition setting, flow boundary. This is the flow of the aircon, air inlet. Okay. So instead of giving 25 degrees Celsius, try we give 18 degrees Celsius. Okay. Alright. Maybe this is also 18. Okay. Right. So, okay. So let's try to do the simulation. So this one, since we introduce a new model, table and the mannequin, we need to remeshing again. So do the meshing, gridding, and then just grid, and you can see the number of elements 200,000, just do the machine. Okay, simple. So how to see your machine? Activate back the root block. This is your root block. Okay, just save this file. Okay, so basically, okay, I want to show you this is steady state first. After this, I'm going to show you the transient states. Okay, you can exit this one. Okay, open your file. Okay. Which one, yeah? Alright, this solver file. Just okay. Let me delete this one first. Okay. Okay, I want to export the solver file. Alright, when I export, they give you two files, the mesh file and the solver file. Okay, just drag and drop here. Okay, once you can see, it's already registered because you drag and drop previously. Just click here and execute. Yes. Now it progress for the view factor because every view factor for the radiation will be calculated. Okay, the reason why you employ the view factor, because the view factor will help you create the spatial mean radiant temperature. With the spatial mean radiant temperature, SMRT, you able to output the PNV, or we call as the thermal sensation index for the human. Okay. So can you see the temperature is increasing, right? What is the temperature? The temperature of the mannequin. Alright, we specified the power or the heat produced by the human, 100 watt. Alright. So this mannequin having the constant, having the fluctuating temperature, 36.7. Okay. 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 This is the maximum. Okay, this is not logic, I think. Okay, as you can see, once your solution is not logic, they will give you the error message. Okay, this is your error message. That means abnormally termination until 78 cycle. Okay, so this is detected floating point exception. Our computer, our memory RAM have the binary to process the matrices. So once the value is, can you see the value of the temperature is not make sense. It is power of 34, it is a very big number. So it will create the floating point for the system to process. It is out of the memory RAM. So your simulation won't be able to converge. Okay, so what you can do, now you know that the problem coming from the temperature. Okay.
Doctor, is it human temperature? Is it the human temperature?
Okay, that is from human temperature because why? Can you see here? This is a very good feature that you can detect the problem here. Okay, which one? Yeah, which I can see. This one. Can you see? This line refer to the mannequin temperature, right?
Okay.
So this one, you need to check your mannequin. Okay, just close this one because this is mannequin maximum. Right, just close this one. Okay, you can delete the file. Okay, you go here, you check back your mannequin. Okay,
Okay.
I advise you, uh, instead of putting the heat source, maybe you can put the fixed temperature. Okay, all right. So go to the wizard condition. Can you see we have the fixed condition here? Okay, select the two mannequin and having the fixed temperature. What do you think? 36, right? Okay.
Yeah.
So that means the temperature produced by the mannequin over the time is fixed 36, 36, right? Okay, you can save, you can export again. Okay, after the last machine, geometry related change was added. Okay, this one they require you to remesh again. So just click yes and then export again. Okay, and then close, save. And then drag and drop to the solver. Okay, and then execute. Okay, this is as usual. Initially, the priority they will focus on the view factor, calculating the view factor. Okay, now let's see the temperature of pipes. We have mannequin temperature. Can you see? The mannequin temperature is constant or fixed because previously we have defined the fixed temperature from the mannequin body. Okay, we wait for a while. Okay. After this, I'm going to show you the transient state. The transient state is much more interesting lah compared to the steady state because the steady state we can see only the final result. If you choose the transient state, you can see from the beginning time taken 0.001 until the time taken 30 minutes. So what happened with the change of time, the human sensation feel it will be changed, it will be different. Might be result from the uh, maybe from the solar radiation, different time, right? If what Azhari, I think Azhari maybe want to include the solar radiation because you need to know your latitude and longitude of the building. Okay, for I'm not sure. Azhari, may I know what's your plan to design your classroom? Do you want to include the external part? I cannot listen. I cannot hear your voice. Jabir, may
Yes,
I know what's your plan to design the library internal conditions?
yeah. Actually, for our plan, we going to to design the 8 points of the sampling that we have been covered, and that includes so many objects, a specific object inside the library, which is a table and
chair,
and also human, and maybe also computer.
the bookshelf.
No, the book shelf is excluded from the objects because it's quite far from the diffuser, and we don't consider it, even within the subjective measurement or the questionnaire distribution. Most of the occupant, they are not within the bookshelf area, so our area is just around the window glass of the buildings and within the tables and area and all of these things. And beside that, regarding to the human doctor, we managed to pick the the human in the sitting mode. I mean, they are not standing. They are, when it comes to the metabolic rate, they are sitting.
Okay. So you need to design the mannequin sitting lah, right? Okay. This is the completed. Okay, finished 200 cycle within 3 minutes 28 seconds. Alright. You can see. Okay, this is your monitoring status of the maximum minimum temperature. Just close this, and then you need to see the result. Okay, this is the FLD file. Just drag and drop to the post processor. Okay, can you see this? Okay, this is your result. Okay, this is interesting because we want to investigate what happened when we place two mannequin having a fixed temperature. So this is the plane view. Okay, and then this is the coordinate. Of course, you want to adjust the coordinate, right? And then you want to see the temperature. Okay. Can you see? Okay. This is human. Okay. Do you notice something that there is no heat transfer between human and the outside, right? Supposedly, there is the convection of heat transfer because the air is moving around the body. So you notice that what is the issue here? What may I know? What is the function that you miss to include in setup boundary condition? Can you guess? Azari?
I think sorry again, I just fix my mic. Sorry.
Okay, why there is no heat transfer exchange between the human body and the external within the internal room?
I think it's because we have not include the convection factor.
Okay, yes. So we must include the convection factor because why? Because we want to convert this human. Okay, so just go back to your step file. drag and drop. Okay, you need to see. Okay, for example, our skin, there is the convection between the air circulate around our body. So you need to, what you need to do, go to the wizard condition. Okay, as you can see, when you go to the wizard condition, under thermal boundary, okay, everything, for example, the wall, there is the conduction. However, the human, there is no convection. So you need to do something. So you need to register the human surface as the skin. Okay, the skin mean it is the medium of the heat exchange. So go here, edit part face. You need to select all the body. 1, 2, 3, 4. Okay, 5, 6, 7. Everything. Okay. So you just register. Okay. This is skin 1. Okay, just register. Okay, and then you can register this as skin number 2. 1, 2, 3. Okay, you can register the skin. Okay. Okay. So everything has been selected. Just register as skin number 2 and register. Can you see the number of face the same? So that means it is correct lah. There is nothing left. Okay, after you have registered, you go to the wizard condition setting. Go to the thermal boundary condition. Now you can see there is the skin. Alright. Select both skin 1 and 2. Select the heat transfer. And what do you think? Okay. You can select the log law heat transfer. Okay, this is conduction, this is log law heat transfer. Okay, if you want to specify the heat transfer coefficient also should be no problem. Okay, let me check what they have done here. Okay. Okay. So just click OK. And then finish. So you can again export your analysis. Okay. Okay, you can close. Okay, just drag and drop here. Okay, and then execute. Okay, while waiting, why don't we look at the case here? Okay, this is the ceiling radiant cooling panel where they have the human rate of heating. This is the wall. They create the wall. this is cooling panel. They create the cooling panel on the ceiling. They create the same, the wall and the window. And then for the air, it is internal inside. And the floor is the wood, wall, brick, sand, window, glass, the human. Okay, they use the water. The thermal boundary is condition. Okay. Okay. Right. Okay, so from here, this is the surface temperature. Surface temperature of the mannequin, you can see. And then, alright, this is the temperature using the heating loads. You include the 100 watt, so it generates from the internal. Okay, surface temperature. Okay, from here, it is 94, 96. You can monitor the temperature. Okay. Okay. Almost complete. Okay, so Azhari, have you done create any model using your SC stream?
Not yet.
Javier?
Well, no, I didn't use the as a stream not yet, but I managed to. I don't know. I managed to done it with with the word uh, with the word. You know. So maybe I will share it with you later on. The
Okay. Okay, now 199. Okay, then we can output. We can see the result. Okay, just close this one. FLD result. All right. Temperature.
um,
Okay. Okay, it's okay. I think we have the issue with the boundary conditions. Okay, what I want to show you is that you see the external temperature outside, and this is inside of the room. Okay, so since we set up the table to be obstacle, right? So the obstacle will not be included in the computational domain. Alright. So from this one, you can actually monitor the go here, extended value. PNV, temperature, MRT, and then this one. Okay, now you can see. Okay, so what is your, what do you think? Your opinions?
I think it's the mannequin is actually in the comfort zone. The PMV is near zero,
Okay.
and there is
It is,
an uncomfort area uh, in below the air conditioner.
yes. So can you see? Just below the aircon, if you place the mannequin or you located here, it is not comfort. It is very, very cool, right?
Right.
Same goes when you are near here, the what we call, okay, when you near the zero PNV as shown in the yellow color, it is comfort area. Okay, so that means you need to adjust a few parameter. So where is the location of zero PNV? So what to do? Go to the surface and then create ISO surface. Okay, what is your variable? PNB. I want to make it 1. Sorry, I want to make it 0. I want to know which location has the better 0 PNB. Okay, can you see? This area is under comfort area, right?
Yeah.
So when you are in this location, then you are feel so comfort. When you feel not comfortable, maybe negative 2. This one lah, it is just near the aircon inlet, aircon outlet. Okay, 81. Can you see? It is very cool here. It is like a it's like a water, right?
Yeah.
Yes, sir.
So near this area or this region, it is very, very cool. Okay, so now you get something on how to utilize. However, you can also view within the PNV what is actually the SMRT. I can hide this. Can you see
Yeah.
the SMRT, the radiant temperature,
Yeah.
as well as the temperature. The temperature is 18.
Okay,
It is
is it?
not
Yeah. Yeah.
okay. So how about okay, this is in terms of, but I want to see my variable here. I want to make sure I want to locate which is the comfort area. 0. Okay, this is comfort area, right? Okay. So in this comfort area, what is the temperature distribution? This is SMRT. Sorry. PNV, go to the contour, go to the SMRT. Alright, even though the radiant temperature is different, but having the same 0 PNV. So this is different temperature. Yeah. Okay, now you understand. I want to show you the most interesting part, the transient analysis. The transient analysis is the time history. This is very important. Okay, can we take a break 5 minutes?
Okay.
Yes, yes.
All right.
Okay,
Okay, Doctor.
okay.
Okay, to all participants, please fill up the attendance link. Okay, so because we are trying
All
to
right.
get a certificate for this course, so if you attend all the session, so we can give you the certificate, insyaAllah.
Inshallah.
Dr. Azian,
Ya, saya.
saya join tapi kadang-kadang tak miss out juga. Boleh isi ke?
Isi je, tak apa. Yang untuk staff UTHM, kita saya akan try minta untuk jam khusus lah. So saya perlukan the number staff tu.
Okay.
Isi je, tak apa, isi je.
Dia kena isi setiap session ke nanti dia minggu depan baru isi semua?
Kita ada satu, the last day will be on Sunday. Isi yang setakat ni punya session dulu lah.
Okay.
Okay.
Nanti boleh sharekan video dia tak nanti?
Nanti Dr. Hidayat dia akan letak dekat dia punya website UTM something like that. So in dalam YouTube lah. So kita boleh access from there lah.
Okay, terima kasih Dr. Azian.
Okay, sama. So Jabir and Azhari, do you think that you can like model a simple modeling of your project during the weekend? So maybe on Sunday we can at least know if you have any problem on that. Is it possible? What do you think?
I think there is no problem right now. I think I'm very confident to make a model.
Yeah, maybe just a simple model, so at least you get the idea.
Yeah.
Inshallah.
Inshallah.
Okay, because we have like 2 days holiday, and after that we will continue with the last session.
Alright.
Okay.
Okay.
Okay, let's continue. Alright. This is what I show you, the steady state analysis. In the steady state analysis, the time is not important. That is why the time is 0, as shown here. The cycle to 100. Okay. One more thing, maybe we want to look at the velocity. So just hide this one. I want to see what happened to my velocity when I place two mannequin and two tables. So go to the plane, go to the vector. Maybe you want to see the contour plot of magnitude velocity. Okay, the difference between the contour plot magnitude velocity, it's only show you the magnitude, the value without direction. You cannot assume that the velocity here is moving in this direction. Maybe this is higher velocity, maybe it is moving to the left, to the right, maybe it is swirling, this happened. So in this case, you only see the magnitude only. That is why you employ the contour plot. Contour plot is used to monitor the magnitude, not the direction. If you want to look at the direction, my advice, together with the magnitude, you need to create one plane. Okay, and the plane having the same orientation. Change the coordinate in y direction. Okay. Now your plane intersect with the plane 2. Alright. So go to the plane 2. I want to look at the velocity vector, the direction. Vector, display vector, and this is my vector. Okay, you can hide this one, you can see. Can you see? Okay, this is my velocity vector. When using the velocity vector, you can see both magnitude. This is the size, okay? Can you see here? The orange color having the longer length of the vector. That means having more velocity, 1.73. Okay, shorter line will have shorter magnitude. This is the direction. Okay, I want to look at the animation. Go to animation. You can see. Okay. Can you see what happened? This flow blocking by the mannequin 1 in front here. And then this mannequin go here. Alright. The most flow happen here. Alright. This is in terms of velocity vector. If you connecting velocity vector with another velocity vector, we call as the streamline. So take a look about the streamline. Create streamline. Okay, now it's already specified at the inflow of the aircon. Okay, that is correct. And then you go to the eclipse. Okay, and untick the create only one parameter. So you can see how the flow, right? It is different. When we have the human, the flow diverge from the human. Okay, this is in terms of the flow. If you think this is not enough for you, you can increase the number of calculation. For example, from 300 to 600. Once you increase the number of calculation, the flow will increase as well. Okay, this is the calculation 100 until here. Can you see the difference? When you do the calculation, this is not finished. The calculation is not complete. You add more calculation, 200, let's say. Okay, now you can see until this one you stop your calculation. Maybe I want 600. I can see, okay, this is complete for me. The flow. right? So it is best for me to monitor in animation. Okay, go to the animation. Go to which one? Okay, go to the tube type. Go to the particle, right? And then you can change. You can set the animation. Can you see? Alright. This is the transparent. If you want to color the model also, should be no problem. For example, I want to color the model, make it to make it interesting for presentation. Okay, just create surface, another surface. Okay, in the region, this is the selection region. That means you select all the part. Until here, click hidden surface. Okay, I want to color only my register component. What is my register? Remember, I registered the skin 1 and skin 2, right?
Yeah.
Okay, so I can color those things. So go to skin 1 and skin 2. Go to the mesh. I want to paint the body of human. Maybe the body is okay, chocolate. Okay. Okay, maybe this is okay. Okay, can you see? Alright. So, okay, can you see here?
Yeah.
Okay, if you want to color the separate things, for example, you want to color the table, you can create the surface again, surface number 3. Okay, go to the region, you need to highlight the table. Maybe you can highlight the table. You need to find which is the location of your table. Okay, can you see here? Table 1 and table 2. Okay, go to the mesh, front and black. Can you see? And then maybe you want the color of the table. Okay, this is your table color. So you can make your animation more interesting. Okay, so far, okay, this is the okay. Yeah. Okay, this is your room. Okay, you can see that when you put the streamline animation, change the color. Okay, you can put the water color. Sorry. Okay, can you see? Now you can visualize clearly, right?
Yeah.
When there is a human, there is the table. Okay. Again, if you want to look at the streamline in different view, for example, this is the okay, this one. This is for the steady state. You can see the streamline it is the best if you can see the transient state. Okay, now you understand, yeah, how to export, how to visualize in different color. Okay, so for this one, I want to show you the transient analysis. Okay, just close this one. Open back your, okay, just copy and paste, control copy. Maybe I want to name as the steady state. Steady state. Okay, another file I want to name as the transient state. Okay, what is a transient state? Okay, the transient state is the property change with time. Okay, just drag and drop. Okay, drag and drop here. So, okay, this is your mannequin. Let's see, this is your mannequin. All right. Okay. Temperature. Let me check the condition. The skin one. Okay. Okay. So for this case, I want to show you how to change from the steady state into the transient state. Go to the wizard. Okay, go to the condition setting. Under analysis type, change from the steady state to transient analysis. Okay. So from here, you can see it is automatically changed from the steady into the transient analysis. Okay, can you see? Okay, go to the transient. This is the cycle. Try to maintain. This is the default value. All right. Under the, okay, how do you determine the time step? Can Jabir, can you explain how you determine the time step?
Okay. I think to determine that the time state is
the time step is the flow crossing all the mesh element one by one. Okay, you want to make sure that the flow of your calculation, remember that I have explained to you previously what is the time step. This is very important. Okay, it based on the current number. Okay, this is the case when you apply the transient analysis, you need to specify the time step. In order to specify the time step, which is delta t, you need to put the current number equal to 1 or less than 1. So what mean by current number? The current number in simple way is the fraction of the flow. Do you understand? The fraction. Is it 100%? Is it more than 100% of the flow? So for this one, can you see? Okay, from here to here, this is the current number 100% going through the mesh, right? This one, the current number, it skip the 10 element. So this percentage, this fraction is different with this fraction. This is 100%. So you must make sure your calculation calculate one by one. So that is why delta T equal to C. C is the current number, which is 1 multiply with the length of your mesh. What is your length of the mesh? We calculate before, we put as 50 millimeter, right? Okay, our nominal standard length is 50 millimeter, multiply with 1, divide with the velocity of the acorn. Okay, this is the velocity of the acorn. So, by having that number, you can put the time step and the current number. So that is the fixed time step. That means you know that you want to make sure the current number is 1, you specify the current number. However, you can ask the program to automatically calculate. This is automatically calculate for you. Okay, when the current number is 0.9, the best time step should be 0.01. Okay. Alright, so after that, go to the file specification. This is very important. Go to the option field file. Okay, this is every second I want to see the result. Okay, every fixed number of cycle, for example, I want 10 cycle, give me the result. What happened for the next 10 cycle? And finish. You can assign export your transient analysis, close this one and finish. Okay, so you need to solve the calculation. Okay, just drag and drop here. Okay, just click here and execute the job. Okay, while waiting, do you have any question to ask? Do you want to ask anything about the view factor, about the meshing, the method to do meshing? There are many methods actually. Detail meshing, align meshing, root meshing. Okay, that one actually I have covered too. The line meshing and the detail meshing. For the root block meshing, haven't covered because the root block meshing is suitable for the electronic component. Okay, for example, you have an electronic board. You want to know the thermal flow on your thermal board, electronic component. So you can apply the root block meshing. It is very good. That is why the reason I'm not teaching you this root block, because it is not you maybe not using the root block method. However, once you do the simulation and then you find error, you want to refine the mesh, maybe I can see whether we can apply the root block or not. But the disadvantage of the root block is that when you apply the root block, I can see you here. I show you. Okay. This is meshing, reading. Can you see here, root block? When you apply, you create the root block, you can specify, for example, you want the table, to refine the table, you want the mesh refined at the table. Okay, you have specific location. That is the root block. However, the root block problem is you cannot do the particle tracking. For example, you want to consider the dust, the flow of dust, the virus, the particle concentration. So root block won't be able to do that. Okay. Okay, can you see this is running simulation? At the same time, they output the program output the result in 10 cycle, 10 cycle, 20 cycle. So you can see the result simultaneously. Okay, so for example, this is 180. This is the transient state. That means it is the time history is very important. Okay, this is 190 cycle. Okay, almost complete. Now complete, right? You can see this is monitoring. Okay, completed. Just close this one. I want to see the result. Just drag and drop. Okay. Okay. Can you see what happened? What's the difference? Jabil, what? Yes, correct. The time, right? This is 5 seconds. Before this steady state, the time is 0, right?
0, yeah.
Now we consider the transient analysis. Okay, the most interesting part is this. I want to show you. Go to the plane, coordinate y-axis. Okay, the plane has changed. Alright. So I want to look at the PNV index. Go double click here, your case project, extended project, extended variable, go to the PNV. And then check temperature, check MRT as Celsius, use as MRT. Create that, go to the plate again, go to the contour plot, go to display and display the PNV. Okay, this is the PNV. Alright. Alright, this is what happened at 5 seconds, right? So what happened at 1 second? So can you see here? You need to double click here. Sorry, you need to double click. Alright. Okay, you need to click here and click cycle. Can you see here? We have 10 cycle until 200 cycle. At 10 cycle, it gives you result into 0.1 second. Double click here. Can you see? Is there any difference?
Yeah.
Okay, this is at 0.1 cycle. What happened when 5 seconds? Is it different?
Yeah, I think
Because
fine.
why? Because the flow because the aircon start to activate, right? Okay, so what happened at 60 cycle? Can you see?
Yeah.
Alright. So the best part, I will advise you, for my advice, okay, you can take the animation in the real-time analysis, okay? So, you go to here, go to the camera mode. Okay, I want to take the video. I want to save, okay, this is PNV index. Confirm that, and then make sure it is at start cycle 10 cycle. You need to select automatic selection, and then this animation will pop out. So from this camera, start the recording. I start recording, start, and then go here, start the animation. Okay, this is, can you see the movement of the hand?
Yeah.
Yeah.
This is the interesting part when you use the transient analysis. This is the PNV, the sensation of the human. The human start to feel sensation. Okay.
Yeah.
Now complete, right? Alright. If you have time, you can increase the number of cycle, then you can increase the time. So finish, go to camera and end your recording. You can see the result. Okay, this is your result. Can you see?
Yeah.
It is smooth tau. It is smooth. Even though you capture one by one here, but the result still smooth. Okay, if you have more time, it is much more better. Alright, can you see the increment of time here?
Yeah.
Okay. So this in terms of PNV, you can see what happened when you have the temperature distribution. Okay, go to the plane. Why I want to look at the temperature. Okay. So what happened to my temperature? Okay, you need to adjust the cycle back, double click. Okay. And then go to camera, you need to rename your video. Temperature. Confirm that. Start the analysis. Go here, automatic selection, record. Okay. Can you see there is the heat from the human, right? That is the convection happen. Okay, Javier.
Yes, doctor.
The human release the heat at constant temperature 36. So now you understand, yeah?
Yeah, inshallah.
Okay, and then go to end, see the result. Okay, this is not smooth again. This is only 5 seconds. So my advice increase more number of cycle, maybe 1000. You can see smooth result, nice result. Okay, do you have any question?
Yes, yes, doctor. If let's say if the aircon is placed in the middle of the ceiling, how the thermal sensation is going to be?
Then you need to calculate. You need to change the location of the aircon. Okay. So that is why you need to investigate. I myself do not know because I never done that. So you need to create the ceiling aircon having a specific flow rate, and then you do the simulation transient analysis, and then you can see what is the thermal sensation by the human. Okay. Okay. For Azhari one, Azhari.
Yeah.
Okay. I want to show you this. The next session, I will focus on the fan part. Okay.
Alright.
This is your model. For example, I don't want to consider any aircon. I want to consider fan. So what should I do? Okay. You can remove the fan. You can remove the aircon.
Okay.
Maybe you remove the aircon. This is a fan only. Okay. Go here. Alright. I don't want the aircon. Okay, what you can do, you can delete or double click. Yeah, sorry. Okay, double click the aircon, and you can consider as the virtual part. That means it is nothing here. It is just a virtual reality, virtual only. Or later on, if you want to include the aircon, maybe you want to check, you want the variable having aircon or without the aircon, you can hide the aircon. How to hide the aircon? You cannot hide like this. Okay, you cannot hide in here. Even though you hide here, the computer still run. Consider there is aircon.
Okay.
This is hide. You cannot see, but the program will know you have the aircon. So how to hide from the program? Double click here and virtual part. You can hide this one. Okay. So that means it is virtually. Okay. So right now, okay. I want to delete outlet. I want to delete. Maybe I want to show you different case. This is air inlet. Okay, that means there is no aircon. But I want to consider the fan. So can you see here? We have the axial fan blow.
Yeah.
We can choose. For example, I want the axial fan. You want your fan to have the casing? We can put the casing. For example, I want the square. I want the round casing. I can preview. Can you see? This is your fan. So you need to, my advice, okay, you want on the top of the ceiling, right? Okay, go here, sketch, edit system, X, go to the Z maximum, update, close, and fit to the computational domain. Alright, from here, you can go to the by mouse, select your fan, select here. Can you see?
Yeah.
Okay, this is your fan. Okay. Okay. For example, I normally use the axial fan. Okay, just click here and place anywhere. Can you see? Without casing, right? Maybe this is your case. So what is your blade number? Okay, you need to change your blade number. Okay, your blade number, maybe you can change.
3.
Okay, William. Okay. Okay. In the fan selection, you can specify the flow rate. What is your flow rate of the fan?
I'm not sure, but I think we can just guess it.
Okay. In the fan type of flow rate, there are two: constant flow rate and the variable flow rate. Variable flow rate is the PQ characteristic, pressure versus the volume characteristic, pressure versus flow rate, volume flow rate. So click here. You can see here. Okay, having different pressure will give you different flow rate. This is actually the PQ characteristic. If you go to the manufacturer, you want to ask, can I have the PQ characteristic for the fan? They will provide you. Okay. Normally, this PQ characteristic will be applied to the factory because maybe factory having the different pressure. I'm not really sure in the fans at the normal classroom. You need to check whether it is a variable flow rate or it is a constant flow rate. Okay, Maybe for the simplicity of simplicity, we can use the constant flow rate. Maybe 7.5 meter cubic per minute. So the swirling type, okay, you can set number of plate. What's your number of plate? 3, 4?
3.
Okay, you can preview. Sorry. Coefficient of this is clockwise or anti-clockwise?
Anti-clockwise.
Okay, anti-clockwise. Okay. So, can you see the direction is correct or wrong?
Wrong.
Okay, so you change the flow direction z-axis to the negative.
Negative.
Yeah.
Okay. So, however, when you do the simulation, it might be problem because the suction of air just near the computational domain. You need to have a gap here so that the flow can move across. So you need to adjust the position. So what is the position? Z-axis. Maybe 200. Okay. Okay. Can you see here?
Yeah.
Because why? Because when you have having the certain length, the air from behind can move here. Okay.
Like actual ceiling fan.
Yes. If you very close here, there is no air because this is blocked by your computational domain. There is nothing here. Do you understand? There is no
Yeah.
air.
Yeah.
Okay. So you need to have a gap. Actually, this is my experience before lah. I try to do the simulation just near giving the error. Okay. So this is your fan model. So you need to know the speed of your fan. Okay. Whether clockwise or anti-clockwise, the thickness, everything. Okay. So maybe you can change the thickness, the size. I want the size to be 1000, 1000. Okay. You can actually adjust this one center. I want to adjust maybe this one thickness. Okay, sorry, 500. Alright. Okay, I think that's it. Actually, you can adjust this borehole diameter. Okay, let's see what happens when you do the simulation. You can export. Before you export, you need to do the meshing. So just go to meshing, reading, and meshing. So you have 200,000 meshing. So just go here, export your result, and then close this one, and then simulate that. This is without aircon here. So what happened when you have aircon? Okay, when you don't have aircon. Okay. So you can actually view what happened when you have the fan about the sensation, human sensation. So of course, Azhari, when you design this, you need to consider the window, right? The heat ventilation. So in this case, there is no heat. There is no heat release, heat sink. Okay, there is no heat sink. Okay. By the way, we can still look at what happened. Okay, now it is 12 cycle. So in the meantime, okay, we can see the result. Okay, just drag and drop the result. Okay. and this is the plane view, coordinates. I want to look at the temperature. Okay. Temperature, nanti open. Okay, I want to look at the velocity. Can you see? You have the fan, right?
Yeah.
So that means it gives you the flow of air from the top. Okay. So maybe this is not complete. This is better. 100 cycle. The more number of cycle will give you the stable calculation. Okay. Alright. This is your plane coordinates. Go to the contour plot. Display the temperature. Okay, the temperature nothing. Okay, because we never introduced the aircon, right? So we can actually, okay, Azhari, when you do this simulation, you can introduce the heat coming from the external, because previously I set the external temperature same with the internal, right?
Yeah.
For 40 and 36, it doesn't make any difference here. So in your case, you can try to, okay, set the external temperature maybe 40. So from here, you can see the vector. Can you see?
Yeah.
Okay, the vector, and then you can play around with the animation. Okay.
Yeah.
This is how the flow looks like lah. Okay. Right. PNV. Even though you put the fan, but you can still activate the PNV. For example, I want to look at my PNV status for the contour plots. Can you see? Is there any difference?
Yes.
Okay. This is without aircon, but the human release the heat. So now you consider the human release the heat, right? Without previously we put the aircon, you can see the heat generation. This is convection because of the airflow around the human. It carried away the heat from the human. So the heat sensation, I think this is better because they carry away heat from the human being because of the aircon flow rate. Okay, which is better? What do you think? Which is better?
I think this if the human actually feel comfort around their head and their body feel a little bit uncomfort, I think, because it's maybe because of the velocity is lower, and yeah, that is my opinion.
Okay, Jabir?
Okay, doctor. You mean comparing with the air condition, fan and air condition? I think from what I see is from this model is the aircon. Sorry, the fan, because mostly you can see that it's reached to 0.14, which is mostly neutral to the human, and the air is blowing to the human body, which is releasing the discomfort from the body,
Yes.
and make them a little bit comfort, within the range of 0.14, I think.
So
Comparing
actually,
sorry.
the velocity play important role lah in the thermal sensation. So you can see, right, the different your having the changing the temperature alone or changing the velocity of the fan will give you different thermal sensation by the human.
Yeah.
So Dr. Azian, do
Ya,
you
Doktor.
want? So okay tak? Macam ni kan, we can see the different.
Yeah, it's very interesting, I think, because it's embedded PMV, and also we can do the ceiling fan simultaneously. Okay, I think it will help Azhari a lot in his simulation, hopefully. So I asked them to apply all the knowledge on this 2 days, so that on Sunday maybe they can show you what if they encounter any problem with their model and so on.
Okay, on the third session, I will do the demo a little bit, and I want to validate more on your performance, whether you understand or not. So try your best to master basic thing first, and then it's okay. I will guide you step by step.
Okay.
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 So for other participant, if you have any question, you may ask maybe on Sunday. Okay, so I think that Hidayah is really exhausted right now. Okay, but thank you very much, Dati Hidayat. So we can continue, I think, on Sunday, inshallah. But I